Given A, the 3 by 3 matrix with entries 1, 0, 0, 0, 2, 0, 0, 0, and 1, find A squared, A cubed, A to the 4th, and A to the nth power. We'll start by finding A squared, which we can get by multiplying A by itself. Because A is a 3 by 3 matrix, we can multiply it by itself because the inner dimensions are equal to each other, and the result will be a 3 by 3 matrix as well. We need to take 9 inner products to figure out what the 9 entries of the resultant matrix are going to be, but many of them are going to end up being 0. In fact, 6 of them are going to end up being 0. You can test this out for yourself. What I want to do now is I want to focus on the 3 that will not be 0. So for the first entry, we need to take the inner product of the first row and the first column. When we do that, we've got 1 times 1 plus 0 times 0 plus 0 times 0. And 1 times 1 is 1, and the other terms are 0, so we're just left with 1. Next, we want to find the middle term, so we're going to have to take the inner product of the second row and the second column. When we do that, we've got 0 times 0, 2 times 2, and 0 times 0. The only non-zero product in there is 2 times 2, which is 4. And then lastly, we need to find the lower right entry, which we can do by taking the inner product of the third row and the third column. When we do that, the only product that's not 0 is 1 times 1, which gives us 1. So A squared is the 3 by 3 matrix with entries 1, 4, and 1 on the main diagonal, and zeros everywhere else. Let's take a look now at A cubed. A cubed is A times A times A. And we've already done A times A. That was A squared, which we just figured out. And so to get A cubed, we need to multiply this by A. Again, when we multiply these two 3 by 3 matrices, our result is going to be a 3 by 3 matrix. And just like the last problem, there are going to be 6 entries that are zeros. Again, I'll ask you to test that for yourself on your own time if you want to verify. So this leaves us with 3 more entries that we need to do. Let's start by looking at the upper left. To figure that out, we need to take the inner product of the first row and the first column. And when we do that, the only product that's not 0 is 1 times 1, which gives us 1. To figure out the middle entry, we need to take the inner product of the second row and the second column. The only part of that that's going to be non-zero is 4 times 2, which gives us 8. And then for the last entry in the lower right-hand portion, we need to take the inner product of the third row and the third column. And again, there's only one part that's going to be non-zero. 1 times 1 gives us 1. So A cubed is this 3 by 3 matrix with entries 1, 8, and 1 on the main diagonal, and then zeros elsewhere. At this point, we can probably see a pattern if we look at A squared, and A cubed. Each of these is a 3 by 3 matrix with 6 entries that are zeros, and only along the main diagonal do we have entries that aren't 0. And the main diagonals in each of these start and end with 1. The only thing that's changing is the entry in the middle. We've got 2, and then we've got 4, and then we've got 8. Any guesses what the next one would be? Well, the next one ends up being 16. These middle entries are effectively the powers of 2, which we can already start to see by looking at the patterns that we've established. If we wanted to figure out what a to the 4th was, it's a times a times a times a, which is a squared times a squared. So we could write out a squared times a squared as a product of those two matrices. And if you go through and do the inner product, you will end up getting exactly what we expected. This 16 comes from taking 4 times 4 when we look at the inner product of the second row and the second column. And so we can see enough of a pattern now to figure out what a to the nth power is going to be. It's going to be a 3 by 3 matrix with 6 entries equal to 0. And then along the main diagonal, we're going to start and end with 1. And then in the middle, we've got powers of 2. And specifically, each of these is 2 to the n power. For a squared, we had 2 squared. For a cubed, we have 2 cubed. For a to the 4th, we have 2 to the 4th. And for a to the nth, we have 2 to the n. So by examining a squared, a cubed, and a to the 4th, we can get a pattern that will tell us what happens if we had a to the 5th, a to the 6th, a to the 10th, or a to the 42nd power. And this is our final answer.